Hi and welcome to Geeks for Geeks. Today we would be discussing the problem count distinct elements in every window. So fair enough. So here at this point we are given an integer array, and for each window of size k we need to consider all the distinct elements. So fair enough. So the first four, how many distinct elements it has? It has 1, 2 and 3. Then the next window it has is 4, 3, 2 and 1. Everyone is distinct. So we have the number of values as 4. Then for the next window 1, 3, 4, 2. It is basically 1, 2, 3, 4. So we have 4 elements again. Then we have something like 3, 4, 2, 3. So we have 3 repeating once again. That is why we have only 3 elements. So it is k is equals to 4. Now the very next one is size 2, 1 and 4 is equals to 2 element itself. 1 and 1 is equals to 1 element itself. Then we have window of size 3, that is 1 element only. Then we have window of size 3, 1 element only. Then we have window of size 3, we have 1 element only. So now the very first simple brute force idea we can have is, okay, 1, 2, 1. Basically, what was the test case? 1, 2, 1. Okay, the very first brute force approach we can have is, we can just consider all windows of size k. First, we can consider of this, then we can consider of this, then we can consider of this, and then we can consider of this. And then we can have the count of distinct elements. Like we can simply insert all of them in a map and the number of keys in the map would be there. Okay. So what would be the time complexity of that approach? So that would be big O of n square, like going through all possible subarrays of same size. And the map would be big O of n because at most it would contain all the elements itself. Now, what can be a better approach than this? Let's try to think. The very first subarray is 1, 2, 1 and 3. The next subarray is what? The next subarray is 2, 1, 3, 4. The next subarray is what? 1, 3, 4, 2. The next subarray is what? 3, 4, 2, 3. Did you notice something? That if I give you this subarray and I tell you to create the second subarray, do you need the whole, like do you need to build the second subarray from scratch? If you already have the first subarray, do you really need to do it from scratch? Let's think, let's think. So you can see that from this first subarray, this went out and 4 came in. Like what we can say is the second subarray is nothing but insertion of 4 and taking out of 1. Then again, this is insertion of 2 and taking out of this one, this 2. That would solve the purpose. So now said that, okay, we can have different subarrays. But earlier, as we were building all the subarrays from scratch, so we would have maintained equal number of maps for each subarray. Now then, the same map needs to be used for all the subarrays. Okay, let's see that also. Let's just keep it as it is. See what can be done. The very first scenario is that we would hash the first subarray. So now I would say for the key 1, the value is 1. Like we have one frequency of 1. Then for the key 2, the frequency is 1. Then for the key 1, the frequency gets increased to 2. And then for the key 3, the frequency increased is 1. So now for the first subarray, we can simply say that for you, the value was the size of the hash map, that is 3. Now, what would happen is a new element would pop out. We would have a new element popped out. So, yeah, okay, so that one can be decreased and it got to one. Then we need to introduce one new more element. So again, if that is not present, we would make a map of. Now again, what we can do is, again, the size of the hash map is 4, so we can release 4. Now at this point, 2 needs to be taken out and 2 needs to be inserted. So overall, this would be the hash map only. Like it would become 0 and then again it would become 1. Again, the size of the hash map would be 4. So we can just write 344 at this point. Now this is the part which gets interesting. Now at this point, 1 needs to be taken out. So if we are taking out 1, then it becomes 0. So the key idea is, and it becomes 0, and the new value that comes in is 3. So we would increment the value of this. So now if you see this, then the size of the hash map is 4, but the correct answer was what? 3. What is the problem in this scenario? This is the problem because there is a key which has the frequency of 0 and it is still counted in size. One idea is that we can just iterate over the hash map and whosoever has the value 0, you can just remove it. But that is again big of n and we need to iterate over all of this. And now think of this scenario. We are the one who is converting this to a 0 by just subtracting 1. And after decrementing, if the value of the key becomes 0, then we simply delete the key and that would solve the purpose. Now we would not have any key with the value as 0. Good enough? Saves everything. Like we are the one who are decrementing one by one. So after decrementing, we can just check for that particular key because now we don't need the location. It's like we did some small modification and then looked back if we did any mistake or not. It's simple. So now what I would do is I would simply start and end till the value of k and I would hash it. Then I would have new element, remove the old element. After removal, check. If that is not the scenario, I would remove. Now let us see the code itself. We would initialize a default dictionary and for the first k window, we would increment the frequency. We don't need to bother ourselves. Then we would append the frequency. Done. Now for the subsequent elements, what we would do, this side element we would remove. Okay. This side, new side element we would add. Now after doing that small change, that is after removal, we would check. After removal, this is the point we are removing. So after removal, we will check for that particular key only. If anything has become 0, we would delete them. And every time, now it's fine. The size of the map, the number of key it contains would be written. Now, what is the time complexity of this? Now, the time complexity of this approach is big O of n. Why? Because hashing the values in the dictionary is constant. And then at max, the dictionary can contain all k distinct elements. So the map can at most contain only k keys. That is why the space complexity is big O of k itself. Now let us check if the approach we discussed works or not. Let us just compile and run and see. And yes, this seems working good. Now let us submit this and see. And yes, we got an AC. So that was it from my side. Thank you and have a nice day. Goodbye, everyone.